feeling very inspired today, so I just decided to do a quick tutorial. And it's basically a very simple concept, or I wouldn't say it's a simple concept, but a simple tutorial on a more complex concept. And that's just looking at Go routines within the Go programming language. Now, I'm just going to describe it at like a high level of what it is before I sort of get into it. Let me just shrink my screen down here so we can sort of look at the code once we start getting into it. But essentially, like you could think about Go routines as asynchronous programming, right? Um, and if you've ever dealt with Java or some other language that you have to deal with threads and sharing data between or interacting with shared data between threads and using mutexes to ensure no race conditions and things like that, then it's sort of a similar concept as Go routines. The only thing about Go routines is it's controlled by the Go runtime, so all the context switching happen within the source code of the Go programming language. And I don't know too much if Go exposes that functionality for you to control like the context switching, but I guess that's up for me to explore more. But all things aside, I'm just gonna show a quick example on like how Go routines work and like how to ensure you know you're leveraging them the right way with some tips and tricks. So let's just get into it. 1 second, let me uh, do this so my thing doesn't disappear again. So I am going to just create um, a simple. Okay, so let's just create a folder. So go routine practice, and then, oops, my fault. Routine practice. And then we're just gonna go into that directory, and then it's gonna create a Go file here. And actually, let's just open up the whole directory. So I'm just using VS Code to write my code. And let's just start off with a simple example, or let's just get a working function going here. Okay, so let's just print out hello world, the first program that kind of always prints out. So if I run this, then we expect it to print out hello world. Now the things that we observe here, now we don't worry about this this red line here. It's because I use Go modules, but don't worry about that. So what we observe here is it looks for the main function, which starts the main routine, the main Go routine. And when a Go process exits, it's usually due to one of two reasons, right? Like the main Go routine finished its sequential instructions, or there was like an error that happened that exited the process, right? Um, Now that's essential to know because Go routines run asynchronously to the main Go routine and other Go routines for that matter, right? So there's no telling uh, exactly how they get context switch between, because they're all running asynchronously. But there is some tips and tricks, like I said, that you can control that. So let's just say that we sort of um, wrap this print functionality within a function, right? So if I just call this hello here, we should see the same thing here, right? Print out hello world. Well, let's say I want to execute this function in a Go routine. Now it's a very simple thing to do. What I mean by that is like to actually execute a Go routine is a matter of two letters in front of the function, which is just the Go keyword. So this is saying, hey, take this function and run it asynchronously to other Go routines and the main Go routine, right? Now, what you might think here is, okay, that's running asynchronously. That doesn't necessarily mean, you know, this is actually going to execute within the process because it's running asynchronously, right? And we're just continuing on, right? Basically, it's like run this in the background, right? Just continue on with other instructions. Now, what we might see here is no output, right? We can execute this as long as we want, but see no output. Now, I want to explain to y'all about something is, there's some definitive points that Go will context switch between Go routines. Now, those sort of points, I could put a link to them, but one of I'm just going to discuss two. So one of them is, the Go routine is sleeping, right? It yeah, it's sleeping essentially, right? And once the Go runtime detects that, it's gonna definitely context switch to another Go routine. Another one is it might be doing some IO operation, right? So once it detects that it's doing some sort of IO, it might context switch to another Go routine. And the other sort of times it switches is up for debate. Like nobody ever knows. That's why it's up to you as an application developer to make sure and ensure that no data races occur, right? And you're actually getting the type of functionality that you want when you're executing asynchronous processes, or not processes, but asynchronous code in your process, right? So um, now, with all that being said, let's just execute a sleep command here. I think I got that right? So I have time not sleep and I want to sleep for a second. Right. So essentially, I'm saying, hey, this main Go routine, you could, you know, we're running this Go routine and we're sleeping in the main Go routine. So it's definitely gonna trigger the other Go routine because this is a definitive point that the Go runtime needs a context switch, right? So we should see uh, the hello world printout here, right? Execute again. It's guaranteed to happen, right? Because it detects that sleep and you know uh, it's going to context switch and then execute the code of the other Go routine. But obviously in practice, this is very impractical, right? You're not necessarily going to run sleeps within the your process unless you're doing some special use case that I don't know about. But now Go has this concept called channels, and this can be a whole other topic in and of itself. But this is one way to essentially control how your Go routines do execute and have some sort of definitive outcome of your process, essentially, right? And it's very simple to make a channel. So, you use the keyword make and then say, I want to make a channel of string. Right? So essentially, this channel accepts strings that are sent to it. And say that I have this function taken. So yeah, this function will take in this channel, right? And also it'll take in let's just say it's going to take in a greeting, which is also going to be a string, which is going to be essentially this hello world string, right? Now, what happens is we can pass in this channel to this function, and then we can also pass in the greeting that we want to, you know, have, right? So on this channel, we could send this string over on the channel, right? Now, this is like the syntax that it leverages to send to a channel. So basically, you're sending to this channel, and send and receives are blocking operations, which a blocking operation what denotes the Go runtime should context switch between Go routines, right? Um, so if you think about just blocking operations in general, then you have a better sense of okay, this is context switching or this is not context switching, right? So um, now that we see this is sending over the channel, we can also receive from the channel, right? And that's just um, having the arrow coming out of the channel, meaning this is or a variable, or it doesn't even need to be a variable, but um, the channel is being received on, right? And we can receive it on a variable. We can assign it to the greeting up here. We say, hey, whatever's being received here is stored in this greeting variable, right? And then we could print out this greeting and then sort of see the operation of it. So we see that and see hello world here, right? And it's much more controlled, much more, like this is sort of the Go way of doing it, right? That instead of just sleeping the Go routine, which is very unpredictable, and I mean, there's not a lot of use cases where you would do that. So, um, this is just a very simple example of like how, you know, basic usage of Go routines and channels, right? There's obviously a lot more to be said about it, but at least it gets you thinking in the right direction on um, how Go routines work and understanding, the asynchronous nature of it, running asynchronously to other Go routines, especially the main Go routine, right? And knowing that the process exits when either, the main Go routine finishes its instructions or, errors out essentially, right? But yeah, that's all I kind of wanted to present here. Um, as always, just keep supporting the channel, like, comment, subscribe, and hopefully I'll see y'all back. Appreciate y'all.